Hello everyone, welcome to a small supplemental video for multidimensional arrays in Java. The notes do a very good job describing some of these concepts, and there is an extra file called mtable.java that I highly recommend looking at to show you how these arrays are created and looked at. Now, before we go ahead and delve into how we code this, I want to kind of set the groundworks of what we're going to be assuming about dimensional 2D arrays. One concept that we're looking at is the way you can understand these to be implemented is very similar to a table. Now, the two components of a table are, as we all know, rows and columns. So you might have already seen the syntax in the notes, but the syntax has kind of these double sets of brackets where we can look at them. Essentially, you can kind of consider an array that is two-dimensional to be an array of arrays. So let's just say I have this main array with these black brackets here, and I have inner arrays inside of it, like so. And you can consider these guys inside of here to be these red guys will be the columns, and these black brackets over here, excuse me, these two black brackets will be the rows. So what this is, if we have a code that creates something like this, what we would have is a single row with four different columns. Now, this looks a bit high level, and it's kind of hard to see this in the code transferred over here, but you're going to be dealing with a lot of rows and column concepts in a lot of these dimensional array areas, multi-dimensional arrays. And one thing that we can just assume going through every example as well is that they're always going to have the same amount of, the rows won't change in value. So you won't have a row with 5 columns or a row with 4 columns, or there won't be different lengths for any of them. And that is where we can kind of have this hard-coded aspect of some of our code that isn't it might look a bit random when you see it first time, but because we're assuming all the rows are of the same length, it will be true like that. And again, you can see tables in lots of aspects, such as on Google Docs and everything as well, stuff like this, where we have the same amount of rows, so 3 columns and 3 rows as well. So that's what I kind of wanted to speak a bit about before we delve into the code. And now we can actually jump into this little file that I put together for us here, this Java file that I created. And to actually go ahead and create a multi-dimensional array, what we're going to do is go ahead and set our type. And then we're going to provide 2 different brackets. And now immediately you'll see that this is different from what we used to use, where we had just a single set of brackets for our course number as example. What we're going to be using here after you do that is the array name. So I'm going to say table. And then after that, I'm going to go ahead and create a new integer array like so. And I'm going to give it 2 different sets of values. So whenever you're creating arrays like this, remember, we need to provide it a set of values as well. And the first set of brackets will always be the rows, and the second set will always be the columns. So let's just say I want to make a single row with 4 different columns. That is how I would make a 2D array with one array holding 4 other arrays there. So that is a 2D array, an array of arrays essentially, and this will hold essentially what we consider to be a type of table. Now, if I want 2 rows, I would make this 2 and so forth. Let me run my code really quick, and we'll see that we created the array, but nothing really happened. And I do want to show off a few things before we do this here. If I go ahead and print out table of 0, what I'll get in the output is actually the memory address of the array because I'm accessing this first outer array. And what I would like to do is to go ahead and try to access the individual values inside of it. So the way I can do that is by doing something like 0, 0. And you'll notice that this is 0. If I go ahead and try to do it this way, remember I set my length to be 4. So I can go up to 1, 2, and 3. And you'll notice I get a total of 4 different zeros. Now, what might happen if I go up to 4 here? You'll notice I get out of bounds because I only have a length of 4 and I'm going up to 4. So that won't work for me. Now, what happens if I go ahead and I go up to 1 right here? Well, notice that, well, I set it to 1 and I'm trying to access a 1, so that's not going to work either. So you'll see that these guys correlate with each other in their lengths and so forth. And essentially, if we pull back up our good MS Paint example, if I go ahead and let me just go ahead and get rid of this. If I make an array of 1 row and 4 values and 4 columns, What I'll be making here is an array that looks a bit like this. So, like so. Apologies for my drawing skills. And the way that these would correlate with each other, there's going to be values inside of here for our purposes right now because we didn't fit anything into there. Each of these hold the value of 0. So to correlate with this would be the table. I'm just going to put T for table. 0, 0. T, 0, 1. T, 0, 2. And then T, 0, tree. And you can see that when we actually run this code here, we go ahead and get it down. Now to try to showcase, okay, well, how do I get to the next row that I'm working with here? Well, what I could do now is go ahead and, I won't draw it out some more, but let's just go ahead and take a look at the code here. I can change my 2 inside of my table up here to go ahead and be, or excuse me, I can put my rows to be 2. So if I want to go ahead and get to the next row and find out all those items, what I would do now is go ahead and change the first guided row. And you'll notice this runs. We didn't fill them in yet, but essentially that's how we can print out the table. So I just wanted to showcase what this row column idea looks like in the code there. And one more cool notion that we can do is actually go ahead and create an example. Let me grab it from the notes from us. There's a few different ways you can create a multi-dimensional array. You can use the idea of I and J, just like right here, row and column like we did up here. We could also use a nested list initializer list. So what that means is we can go ahead, I'm going to call this table 2, and what this is going to be equal to is a nested list. Let's try to type this in with the numbers. I'm taking this from the lecture notes here. 89. 285. And we could see here that I went and go ahead and I created this column, oopsie-daisy, this new type of table. And what I would like to do is try to access each of these guys here. So if I go ahead, I now have my table 2. And if I do my 0, 0, like so, let's see what happens here. We'll see I'll get to 70. And then my 1 will give me my 85. If I want to access the 95, I can leave this at 1 and change that to 0 and leave that to 1. If I change this to 2, you'll see I'll have a 67. And because we have 3 rows up here now that we're dealing with, we won't be able to go much further past this 2, because if I do try to make the tree like so, we'll get the out of bounds. So again, there's these are 2 different ways that you can create an array. This might be a bit more confusing to determine how to find a row and column directly from there. I do find this a bit easier to say because it's literally like the first one is row, the second one is column. But let's try to make our little idea down here a bit more interesting. And like, how do we actually fill this in with data now? And the way that we can fill it in with data and putting items into it is using this concept of nested loops. So again, a nested loop will be a loop within a loop. And the way that we could start off a nested loop is to go ahead and try to grab the values of the actual table and then fill them in from there. So the first idea that we want to do here is to try to find the number of rows. So one way that we can do this is by looking at our code. So the amount of rows I have in my table is 2. So that means I need my I to start at 0 and to go up to 1 less than 2, because that's the array.length, or the length of the table. And as a little trick here, I'll show one way that, let's just say, for instance, that we don't know how to find the table length, or excuse me, the row length or the column length. One thing that you need to remember is that this is an array of arrays. So the row is going to be the big array on the outside, and the columns are going to be the arrays in the inside. So because all of our rows are going to be of the same length, if we type in table.length, that should give us the length of our row. which is 2, which matches up to this idea. But you might be wondering, well, okay, how do I go ahead and get the length of the columns? How do I know how many columns I'm working with? Well, because our table is going ahead and holding these columns for us, you can access the first index of the table and get the length of that array. Because remember, each column is an array in its own right. So if you click play, it is not, that shouldn't be 24, sorry. This should be 2 for my row and then 4 for my length. And you'll see here that if I change it, let's say I want 6 columns now, this will give me the 6. So whenever you want to go ahead and get the number of rows, you use table.length. And whenever you want to find a number of columns, you use table at index 0.length. And again, because we're assuming that each row is of the same length without differentiating columns, this is totally fine to do for this class. Now, again, later on, you might find scenarios where rows might be different sizes, but usually if you just understand the concepts of row, column in these 2D arrays, you'll be set. So to actually go ahead and fill in these concepts now, what I want to do is go ahead and fill in this table with, let's go ahead and try to start it at 100 and then just increase it by 5 each time. So what I'm going to do is I'm going to create a value. Let me say double. Let's just say it's like a cache. And I'll go ahead and type this in as 100.00. Let me keep it like that. And then what I'm going to do is I'm going to use int of I is equal to 0. I is less than table.length, which again, this is how I get row length. And this second one is to get my column length. And I just want to go ahead and increase my I by 1 each time. And again, an issue arises, though, is that we saw it earlier. When I printed out just my table at index I by itself, again, using this concept of table of I of 0 like so, we got the memory address of table, and that's not what we want. So before we even do anything with I, we need to actually go ahead and try to find the current column that we're at as well. And again, the way that we can iterate through the columns, because they're going to be starting at 0 as well, like 0, 0, 0, 1, 0, 2. Remember our concept of our arrays right here. The way that we can access those is to actually get the length of the row or the columns. So that's going to be table 0.length. And then, oops, let me put j is less than table 0.length. And now I'm going to do j++. Excuse me. And we'll see now, I could go ahead and inside of each of these little column guys, I can go ahead and try to find, I'm going to go ahead and set my table of I and my table of j to be equal to cache. Oh, and let me make this an int for us. Sorry about that, because this is going to be one way to go ahead and do it. And usually, because it was a double, I'm not going to cast it just yet. And what I'm going to do is I'm going to increase cache by 5 each time I add it in. So now I should essentially have a table with an increased value of cache of 5 each time. Okay, so we didn't crash, which is good. And this guy is going to go ahead and print out something weird for us. So what I want to do is go ahead and try to print out the first guy. So I get 100. Now, my 100 is at the top left corner of my table. If I stay at the top row and I go 1 over, I should have increased my value by 5. Now I get a 105 at 0, 1. What about 0, 2, 110, and so forth? So now, again, we don't want to be inefficient with our code and make it so that we are printing out 1 by 1. So again, what we could do is very similar to what we already did with our code up here. I'm going to go ahead and just grab this code. And instead of adding in this cache, what I'm going to try to do is I'm going to print out my value at the table of row and column. So essentially, I'm printing out the values there, and then maybe I'll do $, like so. And now if I go ahead and let me add in a space after it as well. So essentially, very similar to how I put in these values at I and j, I can get them at I and j. And again, a for loop's idea here is that this for loop is going to run once. This for loop is going to run as many times as it needs to. And when it's done, we're going to jump back out to this for loop. And it's going to run as many times. So, or excuse me, this won't run just once. This will run twice. And this will run 6 times for us. And again, it's going to go from 0 to 6, and then this one will go from 0 to 2. So again, let's go ahead and try to print this guy out here, and we'll see. Thankfully, that I have my 2 times 6, so this should give me, if I do my row time columns, which is going to give me 12. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 items in my table. Now, again, you can get a little fancy with this stuff as well. So let's just say, so essentially, this is filling in a single row for us. And then we're going to need to jump down to the next one. So what we can do here is actually do a print line right here. And if I play it this way, now I have 2 rows of 6 columns each. And if I want to get a bit even fancier with this, I can put in a little sign like so right here. And now if I hit play, now it's starting to look a little bit like a table, right? And you can really get a bit invested in this stuff. I know I did when I was first learning it. I would spend a ludicrous amount of time trying to figure some oops, daisy formats out. Let's see here. That doesn't seem to be working too well. Let's go ahead and try to make these guys boxed in here. We could do it. There's a few formats we could use as well. I won't do it entirely inside of here. Maybe this might work for us. Okay, it's looking a little weird, but it's fine. So again, let's, the general idea here is that you are always printing out. I think this one was the easiest for us to see here. You can see here that I have 6 boxes and 2 rows. Now, what happens if I increase this to 3 rows? Now we have 3 rows. What happens if I increase this to 4 columns? I have 3 rows and 4 columns now. So everyone, this is kind of multi-dimensional arrays. They're a little confusing at the start because we have to invest in these double nested for loops. But again, there's a bunch of different ways that you can go ahead and look through them. Before we wrap up this one lecture, there is a file called mtable.java, and this is a really cool Java file that goes ahead and shows you how a multiplication table will work. So again, 0 times 0 is 0. The first row will all be 0, right? Because 0 times anything is 0. The second one is going to be 0, times everything by 1. So we go ahead and do it there. And there's a question here that I would like you to ask, try to answer, is how do you go ahead and try to change this to an addition table instead of a multiplication table? Again, everyone, this is 2D arrays. Please make sure you have single arrays, like in the array practice done first before doing these ones. And again, if you have any questions, please post them in the discussion boards. Thank you, everyone.